Hi there, my name is Filip. I'm the program manager for Umbraco CMS, and I'm here to tell you about the future extension APIs for Umbraco BackOffice. And that's what this talk is going to be all about. So I think I'm just going to state the obvious and say BackOffice is a lot of the reasons why people really love Umbraco. So the editors really like Umbraco because it's intuitive, it's easy to use, it's a great experience when you click around, and developers really like the BackOffice because it is super flexible and you can extend it here and there and do all sorts of nice stuff to make a great editing experience for your editor. So BackOffice has of course evolved over time, and if you've been an old-time Umbraco, you might even remember something like this. This was Umbraco 1, the BackOffice of Umbraco 1. If you remember this, you should absolutely write it in the chat so everybody can see, and you can get some nice glory for sticking with Umbraco for so long. Thank you very much. This was when I was introduced to Umbraco. BackOffice looks something like this. This was Umbraco 4 something. To be honest, I was mostly a front-end developer, and I really didn't think Umbraco was that great at the time. I thought the BackOffice was a little nerdy. But then with Umbraco 7, the BackOffice was reimagined. The user experience was redefined. It was built as a single page app. It was the hottest thing at the time. It was Angular.js. Everybody loved Angular.js. It was very inspired by Bootstrap, overlays, modern, nice experience, and it was fantastic. And now with Umbraco 8 that we launched a couple of years ago, we took that to the next level. We're now a full single page app where there's no more views on the server, and the BackOffice is completely decoupled. All the communication between the BackOffice and the backend is HTTP requests and APIs, which made it, of course, it possible for us to make the move to .NET Core on the server side without really affecting how BackOffice works. So with 8, we got the nice rich previews with the block list editor, and we expanded on the panels with the infinite editing and all that stuff. So it was really, really great. We kind of think of the BackOffice as having 3 layers. So there's the user interface layer on top, which is all the sugar, all that the users actually interact with. So all the buttons and drop downs and forms and text boxes and all of that stuff is in the user interface. And on the bottom, there's the implementation, which is that holds all the logic about how to communicate with the server and how to authenticate, how to enforce all the validation stuff and all of that stuff. But today, we're here to talk about the API layer. The API is how you extend BackOffice, how you build custom property editors and dashboards and all of that stuff, all the power and the flexibility that you have as a developer. That's what we're here to talk about today. But some of the challenges we're seeing in the API today is that the API is pretty limited. It's really well documented, and it's a nice and super experience to work with, but it is a little bit too limited. And that has led more or less to a limitless API because developers are creative, especially in the Umbraco community, I think. So they've just been looking at how stuff was implemented and duplicating a little code here and there, picking out some class names to make something look like something else. And if you needed some data that wasn't really available, you could probably find it on the root scope somewhere or climb up a couple of scopes to get it to you. So this was really creative, and we've seen some amazing projects built this way. But it is pretty bad practice to do. It makes it really hard for us to do any significant rework of how BackOffice is actually built, because we don't really know what properties you're expecting on what scope and where to climb for what. So it also makes it pretty hard for you to test your components in solidarity, so like on their own, because they depend on so much stuff that you can't really just mock out. So we've seen people do stuff like this, where you climb 4 parents to get some kind of scope value that you need. I'm really not trying to point to anybody specifically here, because this is actually from our own stuff. So we're even ourselves doing bad practice stuff in the BackOffice today. We've also seen probably the most popular hack to Umbraco is to intercept the request for a template of something, anything really, and then in that request replace it with something else, which gives you the power to, in this example, take out some elements that you don't need. This is actually from hardcore, so our headless offering, we're taking out some fields of a form that only apply in a headful or in a traditional CMS context. So it enables a lot of things, but it also breaks very easily, and it makes it hard for us to give you a great user experience and developer experience with Umbraco. So let's do something about all of this. We want this to be an open process. We want you to be part of this process. We like to say that open source is not about democracy, but it is about transparency. It's about being completely transparent about the process, the decisions that we're making, all of the thoughts that goes into this. We want to put them out there so you can join and we can get the best of not only the brains at HQ, but the brains of the entire Umbraco community. So we formed a new community team just to work on this. Of course, it's all still open source. The UI library that we've started working on is open source as well and available on GitHub today. And we're using our RFC process where we ask for comments on changes that we intend to do. And we do that out in the open for everybody to see and follow along. And we will continue to do this also with this project. So for this API layer, we think that a great solution is to make sure that we define the API very well before we actually start implementing anything, before we start looking into what framework to use for the implementation and all of that stuff. So we want to make sure that we support the use cases that you have, but we also want to be attractive and familiar to people that doesn't necessarily know Umbraco. So we want it to be more of a modern front-end kind of feel and easily recognizable and understandable for people. So we want the API to be built on web standards and not any framework. And that's why we're making all this work now, so that there won't be we won't have the problems that we have today where you look into the AngularJS implementation of BackOffice to find something when you need it, because with this API design you can't do that, and we're defining all the APIs before, so we don't get into the trap of saying, oh, you can just get that by doing this or that. So we want the API to be built on web standards. We want it to have a great developer experience. So we want to build it on TypeScript. So this does not mean that you need to use TypeScript. If you don't like it, you're free to use just plain old JavaScript, and all the APIs work the same. We just think that having definitions of the API as TypeScript will give you a greater experience as a developer in your editor, even if you're just writing JavaScript yourself. So we think this is really key, and this is pretty much the only decision we've made about the API so far. We tried to draw out like all the extension points that you have today and all the services and utilities and all of the stuff that is in BackOffice today, and it is a monster. It is super complex, and we want to make sure that we cover all of this. So I'm just showing you this to say that this is no small feat. This is actually a pretty huge project, and we want to make sure that we think all of this through before we make decisions. So of course, we don't want to just invent anything or everything ourselves. We want to, learn from people that have gone before us, people that are smarter than us, so we've read 1 million blog posts probably. We're talking to people in communities about what they do. We've looked at some of the competing CMSs and what their extension models are like. And I want to just mention a few that you might want to look into as well. There's a really nice book called Micro Frontends in Action that explains actually a lot of the issues that we're seeing, and it comes up with some great answers to them. One of them being web components and how you can communicate between independent components that doesn't necessarily know each other. We've looked at the fast framework from Microsoft, which is a tiny little web component framework, but that also gives you stuff for dependency injection that has inspired us a little bit as well. there's a pretty great talk about how to build more complex stuff with web components, build stuff like dependency injection and stuff by Justin Fagnani. And there's a great repository on GitHub. There's a lot of them, of course, but there's one in particular from Microsoft about using Redux in this kind of scenario. So other than that, we've had lots of inputs through some of the previous RFCs. We did a workshop day. We wanted to, of course, invite the entire world, but the thing we could do, COVID permitting, was 10 people in one room in Denmark. So that's what we did. We still thought that was better than nothing. So we gathered some product partners, some gold partners, some MVPs from different places. And we got together for a good afternoon of just talking about the back office and what we liked and didn't like, and what we wish were different, and started talking a little bit about what things could look like. And we've just had lots of great inputs from everywhere. So we're really excited about all the inputs that we've gotten. So I want to show you some code now. The code is by no means anything you should use in production, of course. This code is probably not gonna be code that would actually work, but these are trying to show what some of the APIs could look like, how it would feel to you as a developer to actually use them. And that's really what I'm trying to achieve here with showing you code. So don't, there's probably coding mistakes in the code and all that, and that's fine. This is just prototypes, explorations. Some of this is not even a prototype, but just an idea, and that's all fine. But one of the things that we found from a couple of the books and sources of inspiration that we've looked into are web components as a solution to some of this, and that kind of struck a nerve with us. We think web components are the browser native way of building components, just like you do in React or Vue or Angular or Svelte or whatever you use today, but just from the browser. So it's a little more low tech, but it gives you encapsulation, and it is built with the DOM, which means it just works out of the box with all your frameworks, because they know how to work with divs and inputs. They know how to work with web components. And it works with all the browsers today already, and it will continue to, because it is a web standard, so there will be no breaking changes to that. So the first thing that people think of when they think about APIs in the back office is probably, how would you build a custom property editor? We imagine that this could be a web component where there would be more or less 3 API surfaces where we just look at properties on your element. So it's an element like a div element or something. It's just the element that you define, and then you put properties on them that we interact with. So there will be a value property, which is mandatory, where we will give you the initial value, and you will update it probably with some kind of getter setter magic or something to the string that we will eventually store. So as the editor interacts with your component, that's what will happen. Then we will give you a config property, which is going to be all the pre-value stuff that you know from day. We're just going to give you this once, and then you can do with it whatever you want. And then we'll have an optional check validity function that's async, where you can return some kind of value to us, whether your component or whether your property editor is valid at this time. So that could look something like this. So if you haven't seen a web component before, this might be a little bit complex, but it is more or less just a class that extends from the base HTML element class that all the DOM elements extends from. Then in the very last line, you see that we're defining it, we're giving it a name, and there's a rule that all the names must include at least one dash to not collide with the browser elements, but we think this is actually a good idea, so you can have some kind of namespace, so you don't collide with the Umbraco ones, and you don't collide with other packages and stuff. So we would encourage you to use that as a way of namespacing your stuff. So in here, I'm just implementing a render function that could be a way to do it, where I'm printing out some value based on the value that I get from Umbraco. you see I've set up a getter and setter pair that just takes care of the fact that we're actually working on a rich JavaScript object, and we want to make sure that what we send to the back office or to the backend is actually a string, so it takes care of JSON serialization and all that stuff. And then it takes care of actually calling the render function whenever the value changes. So if something outside would change the value, maybe it's being updated through like an infinite editing panel or somewhere else, we would actually re-render the view and update what the user sees. Then there's the async check validity function, where we just look at a config value to see if it's mandatory, then it needs to have a value to be valid, or otherwise it's just going to return true and be valid. So this is a pretty simple way of what a property editor could look like. And I mean, the basic example we always use is how would we build the Google Maps thing, where you can drag a thing around and we would actually store the latitude and longitude. And that would be something like this, so not too many lines of code. You see that the setter on the value here actually sets the course that then moves the map around. And in the connected callback, which is the lifecycle hook for when the element is actually started up, we do all the loading of the APIs and initiating the map. And we register a listener for the drag event. And then that calls a local function on the instance that's on drag end that then updates the value. And then we imagine that in the check validity thing, we're actually calling out to an external API to see if the coordinate is within some kind of legal bounds of something. So that's just imaginary. But you see that something like this would be pretty simple to build and pretty straightforward. And all of this, as I said, there's no frameworks. All of this is browser native and it works today. Yeah, so instead of all the scope things that we're used to in AngularJS, more or less everything is tied to this. So instead of scope or model.value or model.config or model.validation, we set all of this on the instance of the element instead, and you can read it from there. So this solution would kind of work more or less like anywhere we use ng-include today. And that's a lot of places. So dashboards and sections and content apps and dialogues and all of these things we could probably solve in this kind of manner. We imagine that instead of today where in your package definition you kind of describe that there's this JavaScript file and then there's this template file, you would instead describe still a JavaScript file, and then you would just describe what the element name would be, and then we would take care of spawning that element and mounting the properties on it and all of that stuff. The UI library that we've built or are building is actually built with this pattern. It's built with web components, and it gives us a super nice development experience. So if you want to add an Umbraco button inside of your Google Maps property editor, you just use our elements and they work directly. And the developer experience that you get from our elements, you would have on your own elements as well, as long as they are proper web components, and that's what we do. So I made a little screenshot just to show you that VS Code in this case actually knows what elements are available, and it knows what attributes they have and what value they can have, and you can get all of this just out of the box with the UI library today and with your own components as well. So then the question is, how do we deal with dependency injection? So today in AngularJS, dependency injection is basically a big bucket of dependencies where you can add stuff to and then you can get stuff out of the bucket. But we would want this to be a little more hierarchical. So we would like to build this on a tree where there's a root injector at the top, and then you can have sub-injectors. So you could actually override dependencies for a certain part of your application. So imagine that we have a notification service, and when you ask for that, pretty much anywhere you get the root one. But when you're in an infinite editor, maybe we would like to give you a different notification notification service instance that then shows the notification in the overlay instead of showing it behind it. So for scenarios like that, we think that the tree-based dependency injection really works well. We're looking at a use case right now where we're building it on the DOM. So anywhere when you want a dependency of some sort, you emit a DOM event, and then we hook into the DOM events because the listeners are synchronous. you can just emit an event, and then we can look for that event, and whenever we hear it, then we just mount the instance of the service that you're looking for directly to the event, and then you can read it out in the next line of code because of the synchronous nature of events in JavaScript land. And since it's based on the DOM, that means that the root injector would just be on the document, and anywhere below you could override a dependency, and you would then get the local instance instead. So it would look something like this. You see that in the connected callback here, I make an event that's called request instance and send some kind of key along with it. I dispatch it, and then immediately after, I just say, I know that I have an instance now on the event, and I can just save that as a local property here. Then whenever stuff happens, whenever you click a button or whatever, then you can call methods on the service that we've just injected. And you see here that we're dispatching the event on this, which means that we're dispatching on the element itself, which means that this would give us the local representation or the local version of the instance. This would bubble all the way up, and if it's not overridden, then it's just going to be caught by the document at event listener. But we could actually do it directly and just dispatch to the document directly and skip all of the hierarchy stuff and just get the root one if we wanted to, in scenarios like this where we want to open the infinite editor or something like that. This, of course, is a little bit much code to write, so we've looked into how we could make this prettier. And I kind of like in JavaScript as a proposal still, but in TypeScript it's supported today. The decorator pattern where you see in line 2, we're just calling add_inject with some argument, and that will take care of doing all of the wiring for us and emitting the events and assigning it to the local property and all of that stuff. So this is basically a very simple way to get the editor service here is just to call add_inject before you define the property. So another question that we want to discuss is reactivity. Today AngularJS takes care of all of this for us, and that is also the source of all the performance problems that you see in BackOffice today, because anything can change anything else anywhere from anywhere in the code. And the way it works in AngularJS is basically that they take anything that's asynchronous or a user gesture, so promises or web requests or timeouts or click events or anything like that, and they wrap that, and then anytime any of those events happen, then we just tell Angular to look through all the templates and basically re-render them again. So we've looked at how do we get that kind of experience in the next BackOffice, and what could that look like. So the pattern that we come out of the box with this approach is that we have setters and getters on the properties, and as data always flows down, as soon as something is changed anywhere, the data would automatically flow down. That would work if components would always know about what children they had, and it would work when you're always passing along simple values. But as you know, in JavaScript, we might oftentimes pass down objects, and that would require the objects to be immutable, which would make it a little bit harder to work with. And I mean, reactivity sounds a lot like React, so we thought, let's take a look at what this would look like with Redux, because this is the problem that Redux is solving. And in Redux, you have a store that's a global store here. I'm using dependency injection to inject it. And then, of course, we could make this even simpler with some kind of mix-in or something. But for now, it's just explaining that we could have a store that you could subscribe to. And then if you wanted to do something, you would dispatch events on that store. So you see here in line 10, I'm calling a dispatch event that's called getContentById, where I'm patching in the content ID. And that would then trigger something to down the line, update the store, or update the state that's stored in the store. That would then fire my subscription that would call re-render and update the local state. So there's a little bit of logic going around here, and there's some things about this that I really like, and then there's some things that I think is a little bit complex. So, but we also looked about what would this look like with the pattern that's more like what they do in AngularJS, or not AngularJS, but the new Angular, where a lot of this is built over observables. And in the observable pattern instead, we would have the content service. Again, we would inject that instead of the store. And then we would call methods on that would then give us back observables instead of one time giving us the data that we want. It would kind of have the same pattern where there's a subscribe method where you would then be notified anytime the data that you asked for initially is updated from anywhere else. So we could imagine something like that. That might work well as well. But it is it is quite a lot of hand-holding for you as a component creator to do all of this wiring yourself. So we're looking into different patterns, but I don't think we have anything to show about that yet. But just showing this to show openly where we're at. And of course, for both of this, I mean, all the anti-patterns are more or less there, so you should of course unsubscribe when you're subscribing. And as I said, we should probably have mix-ins that could help you a little more with this. And for the Redux example, maybe the whole mapping state to props and all of that stuff we should build as well. But yeah, so that's some of the things that we're looking at. And I mean, does that mean that we all have to learn web components? Again, I want to say we're not sure yet. These are just thoughts. I would say web components would probably be a good guess. And I mean, learning them is good anyway. But one of the things that we like about web components is that today, actually, most of the frameworks, they have a way of using web components, but they also have a way of kind of exposing themselves as web components. So you could build your property editor in React or in Vue or in Angular, and then you could expose it as a web component that we could then use inside of Umbraco. So you would get all the benefits of your framework, but it's not tied to how we build Umbraco. So in Vue, it looks something like this, where you just define your component and there's a wrapper method that you call that then gives you back a web component. And in Angular, it's a little more code, but it's essentially the same thing. You call create custom element with your Angular component and some injector, and then you get back the element that you can then define. So the moral of this story is this is a super exciting project. We don't really know yet where it's gonna go, but we would like you to be part of this process. Tell us what you think. Tell us what you think about the examples that I've just shown. What you think is terrible, what you think is awesome, how you like the tools that we've shown. Take a look at the UI library. How do you feel about that? And give us all the inputs so we can together make this API and make it really, really great. And with that, I'll say thank you for listening, and be sure to friend me on Twitter. I'm happy to take questions there or in the Q&A session later. Twitter is always a good place to get a reach of me if you have something, and my DMs are always open. So thank you.